Well, thank you for coming to the very last talk. I'd like to tell you something about using RCPP to solve Sudokus. I guess most of you know what a Sudoku is and how you can solve one. I think you also know it will take quite a bit of time to do it, and it's actually a bit trivial, maybe not so exciting to do it. So I wrote a computer program, and that's what you do. And then I wrote it in R initially, and I thought, well, I can do it like this, and it was not so fast. So I thought, well, maybe it would be nice to make a faster computer program that can solve it really, really fast. And I'd like to tell you something about that, so how you can use C++ together with R to create faster solutions for your problems. I also warn a bit about doing this, because sometimes your R solution will just be easy to optimize just using R, or maybe it's not so interesting to do it because there is some overhead in using C++. Well, you have to learn C++ first of all. It's minor. I will show you it's pretty minor because the way that RCPP package is set up, it's quite easy. So I hope this is all already familiar information. This is how you do a Sudoku and how you solve one. I don't think this will surprise anyone. So let me go quickly. So yeah, like I said, I did first an R solution and then I did a hybrid solution, where I used the best facets of both languages to get an optimal result. So first I need to load the R Sudoku into the computer. I chose this format where basically the 0 denotes an empty cell. Then in this format I could easily keep type it over from the paper and keep the same formatting. So this is the format. And then you can read it very easily into R. And this is where R, I think, really shines. If you do this in a programming language like C++ or Java, most of the time it will take way more lines than this. This is 3 lines, which are all 3 very short. It's hard to do this wrong, I think. I think if you are somewhat experienced R programmer, you think, okay, I do a read table, I make a matrix, and that's it. Then you have a Sudoku in your memory. And that's it. So let me now tell you a bit about the solution strategy I used, which is basically you start at the top left cell that is not filled in yet. You check what possibilities are there. If there's only one possibility, you fill it in. If there's multiple possibilities, you check out maybe the next cell. If there's no possibilities there, then only one possibility, you fill it in. Otherwise, you choose the cell which has the least opportunities to choose. Because, well, the probability of choosing right is highest when you have the less choice. Okay, you could do some very fancy heuristics maybe, but it's probably very easy just to go with the least choices. It could also happen that if you go wrong, that you have a contradiction. So maybe you have a column which already contains 2 ones. Well, or where one of the cells needs to contain a 1 because that's the only value that's possible due to some other rule. In that case, it's just not a correct solution for your Sudoku, and you don't want that because that's not how you solve Sudokus. So let me quickly go over this code. So I know it's late, but there's only 3 slides of code really. Let me go quickly. I also like to tell you about this operator I'm pointing at. Yeah, that works. So this is in the package Z a lot, and it's really nice. So if you return a list, it allows you to unpack all the values you are returning. So instead of writing it to a temporary variable and then getting the 2 values, you just in one go can assign it to 3 variables and then use them. So it cleans up the code a bit. It's pretty nice, I think. I use it a lot. So I try to do the elimination step. I will go into that later. I will say, well, if it is a contradiction, I will stop. If the partial solution is completely filled in, I'm done, yay. And if there are multiple options to go into, I will one by one go through those options. And if the result is still good, I will continue going. So that is basically the basic strategy to solve this problem. Then I have the eliminate function, which just is checking which values are possible. And it is greedy in the sense that if there's only one possibility, it will take that possibility. This is that function. It's also fits neatly on one slide, but just. It uses this choices function, which I will define later. And basically, it says, well, if there is only one choice, I choose that. If there is no choice, I return. And this is not a good thing if there is no choice anymore left for a cell. Or I just update the best suggestions. And that is what I will show next. So this function finds choices. And this follows basically the simple rules of Sudoku. It checks whether it checks in I whether the row is correctly what the options are by the row rule, or the column rule, or the subgrid. So if you know a Sudoku, you know the 9x9 small grids. And basically it starts out with all possibilities and it eliminates those options. And then this is update suggestions, which just tries to find the very best option it can find. So if you have a cell that has 9 different possibilities, you probably don't want to pivot on that, but you do want one that has maybe, well, ideally 1 or maybe 2 options. With this together, it's 3 slides of pretty dense code, but then you can actually solve Sudokus. So I wrote this code, which takes a Sudoku I read in earlier, uses the find choices function I defined, and runs the solver. Now you get this solution. I guess this is a bit more friendly to read. If you look closely, you see this is a very easy Sudoku to solve. It just goes to 1, 2, 3, 7, 8, 9, etc., etc. So this one is found very quickly. If you do it by hand, it would probably still be fast. Especially once you notice the pattern, you can just fill it in. But that's not interesting, of course. That's not why we have computer programs. So I went on Google and tried to find the very most difficult Sudoku I could find. And this is the one. As you can see, it's almost entirely empty. Lots of zeros. So this makes it hard. And what is supposedly special about this Sudoku is you never can solve it by just doing elimination. You have to make, at some point you have to make a guess, see what happens with your guess, and hope it's the correct guess. And if it's not, you make another guess. Well, I solved it too, but then my pure R solution, it took like a minute. And well, I have a pretty decent computer. It should not take a minute, I think. So I did some profiling, because I hope that's what you all do when you see I have a piece of code that's not fast enough. You start the profiler and think, oh, well, what can be better done here? I literally like the Profis package. I can really recommend using that to people. But for this one, because of the tricks I used with the pipe operator and zealot, it crashed. So I used rprof, and then I said, oh, then it's a lot of overhead. I mean, the zealot and the pipe operator are really nice, but they require a lot of non-standard evaluation, and that slows it down a lot. So then this is more for reference. I just removed it. I used more standard R, but it's basically the same code, so I don't think I won't bore you with it. Then I did the same for the pipe here, and you see it's a bit more wordy, but it's still I guess easy to follow. So then I did a micro benchmark to see, well, what did I get for removing those operators, and I see a 7-fold speed up, which is pretty nice, I thought, but I think I can do better than this, and this is where C++ starts to shine. You have written something in R, and it's pretty nice, but you want more speed, because maybe it's a critical business process, and you don't want to have to take 10 minutes, but maybe 1 minute. And then, well, R is not a fast language. I think we sadly all agree with that. So what do? Well, we start the profiler now. After the removal of the operators, Profis works again, and you see this code. I'm not sure how familiar you are with this picture, but basically the bars show the amount of time taken. So Yes. So this is the large bar, but this is also the thing that does everything. And then you see this other bar. That's basically most of the time. That is 4,400 milliseconds out of a bit more than 5,000. So that's more than 80% of the time is taken in this one line. So then that's where you want to go for your optimizations. You don't want to spend time optimizing other stuff. So we try to improve it, and then now I show you the scary C++ code, which is actually not that exciting, I think. And that's good news, because I will later show you what it brings me. So this code is basically the same code as the code I showed you before. The order is quite a bit different because of the way C++ works. But you see these set diffs. Does it select there too? Yes. So the RCPP package has this set diff thing. I put in the candidates, so this vector of 1 to 9, and then I remove the values that are not possible. So this is exactly the same as I did before, as you can see here. So this is again set diff 3 times. I start out with 1 to 9. I remove the row. I remove the row. I remove the column, and I remove the grid. So actually, when I started writing this, I didn't spend much time writing C++, because I just started copying and I implemented it. I had to be a bit careful, because unlike R, C++ is zero indexed, but that was, I guess, the major hurdle to overcome, which is tiny. So I was happy. And then, of course, the big thing is, what does this bring me? Well, that's the new benchmark. And there you see, I think, the point of this talk. I didn't really work hard on this C++ code, but when I look at the benchmark, I see that I have another 7-fold increase in speed. So it used to take 5 seconds, and now basically it takes less than a second. So when I now want to solve this world's hardest Sudoku, I just do it with click, and I wait a bit, but it's not enough time to even look out of the window. It's done. So this is what I really like about the C++ package. It's very easy, once you get the hang of it, to make nice code, but you get so much in times of time one that you then can spend on maybe making nice reports, or, well, enjoying life, but at least not waiting on your computer, which I don't like. So actually, that's it. That's how you get started, and you can do really fancy stuff. And you can see on GitHub or on the CRAN many people using this. This is actually the reverse dependencies of RCPP. Many of you are probably already using it under the hood. It's really useful and it's really used widely, but you can just start in very gently with these small functions that you know that will take a lot of time, but are not so hard to optimize. And then you get compiled code, which is just very, very fast. Because if you look at these numbers, you see that there is almost 4.4 second faster runtime. It goes from 5,000 to 700, which, if I go back to the profile, is almost this amount of time. So the C++ code is 44 times as fast as the original, which I think is a good thing. That's it.
Thanks a lot. Any questions or suggestions?
For our very hard questions, I saw that Roman is also here. He wrote the package initially, so co-wrote it. He really knows how to deal with it. Yes?
And the question is, how hard is it to debug C++ from R?
Could you repeat that question?
Yes. So the question is, how hard is it to debug C++ code from R? It's not as fun as using just R code. It is not as easy. So what I would really recommend is also what I did in this case is start out with a solution in R, which is not ideal in terms of runtime. And then just say, okay, I have this very, very small function, and I write that in C++, and then it's easy to test. I didn't go over that, but you can just use your standard unit testing framework, swap out the definition of your function, and see that your C++ code still works. And if you keep it small, you don't even really need to use the debugger. It is a statically compiled language, so there's also much stuff you don't even have to experience. So there's of course bugs it will catch already in at compile time. On the other hand, and I didn't show that, if the C++ compiler is not really happy with your code, it will show you that in a not so nice way. It will show big error messages, and then it can get tricky. That's true. There's definitely a cost to doing this. So yes, it can be harder than just writing R, but I think in the right circumstance, the reward is there. Thank you.
Thanks again.